All right, welcome back. We're going to do the 2017. Hope you guys are all doing well. Um, Remember, there's a Zoom call tomorrow at noon to go over how to use the TI-89 calculator. So I hope to see you guys there. All right, so 2017, number one. Number one and two are graphing calculator questions. Every question, both questions on the real AP test are going to be calculator allowed because they can't really permit it. So I definitely want to go through how to use it and make sure you guys are comfortable with that. Okay, so left Riemann. So first of all, we got this is in square feet, and this is in feet. So this is kind of a weird. This is square foot per foot. Um, so yeah, this is a rate. It's just a little. It's a strange rate. So the area of the tank gets smaller as we get like farther into it. I think is what's going on there. So left Riemann sum with three intervals. So you're gonna do, the base here is 2 times the left-hand endpoint, plus 3 times the left-hand endpoint, plus 5 times the left-hand endpoint. So that gives you this answer right here. You don't have to show the integral part there, but it was just helpful for me and maybe to explain it to you. Integrate the units, so we are in cubic feet there. Okay, part B, does it over or underestimate? So because these y values are going down, when you take the left-hand endpoint each time, you're taking the bigger of the two. So we took the 50.3 here, we took the 14.4, we took the 6.5. So because you're taking the left-hand endpoint and A of H is decreasing, you're always using the higher y value, so we have an overestimate. And then part C and D here get into cross-section volume, and that is not covered on this year's AP test, so you do not have to worry about those. Number two, we had one in the last one that was similar to this. I think there was sand, but what we got here is there's 50 pounds of bananas, and this is an amount. This is like the original level, and then down here these should be like written a little lower because these are rates. So this is G of T bananas per hour are added. And I should note this is only added between 3 and 12, so they don't start adding them right away. And this is the bananas per hour removed, and they do start to get removed right away. So like as soon as the store opens, there's already some sitting there. People start taking them 3 hours in, they start replacing. So G of T is the rate in, F of T is the rate out, and there are 50 there to begin. So part A, how many pounds of bananas are removed in the first 2 hours? Well, removed is the F of T. So what I want to do is integrate F of T between 0 and 2. And I'm just doing that in my calculator. I haven't actually done this yet. I just looked at the AP answers. I wrote down what they got, but let's just make sure it works. So F2 algebra, no, sorry, F3 calc, we're going to integrate 10 plus 0.8 x times sine of x squared, no, x cubed over 100, comma x, comma 0, comma 2. Okay, sorry about that. Took me a second, but that's what we get. So that is typed in right. You can just kind of verify that it looks like it's supposed to Took me a while to get the parentheses in the right spot, but we get 20.051. And then for showing your work, you guys have a calculator on this test, and they know that. So you're not going to have to integrate by hand unless they think of some way to kind of force you to go through steps. But a lot of it will be doing it in your calculator. So again, get comfortable with that. We'll grab a Zoom call tomorrow. I'll record it if you can't make it. But you can just write down, here's the integral, here's the answer. And, they'll know that you plugged it into the calculator. Same thing with part B. They're saying, what's f prime of 7? So, this is f of x. So I think the easiest thing to do might be to plug this into the graph and then have the graph calculate the derivative when x equals 7. So let's try that. So 10 plus 0.8x times sine of x cubed divided by 100. You're going to want to be in radians for this class, and then I'm going to go zoom. I'm going to do so we'll graph it, and then it's almost for sure not going to be in the right spot. So I'm going to try zoom fit and see if that works. But some of this is the annoying part, is just kind of finding your way around the calculator. So let's try zoom fit, which is supposed to zoom into where the graph is present. There we go. So that is f. So the bananas are getting removed faster and faster. And they want to know f prime. So remember, f is a rate. So f is velocity, basically. F prime is going to be the derivative of that, which is acceleration. So we want the derivative, dy dx of x equals 7. Apparently that's outside of their range. So I'm going to go to the window, and I'm going to make my x go from 0 to 10 instead of 0 to 7. And then graph it again. And we might need to change the y values here too, because it needs to see the graph for some reason, even though, okay, no, we don't need to. So if I type in 7 now, I get negative 8.1195 or 120. And that's the rate of the rate. So that's an acceleration. So it's the rate at which the bananas are being removed is decreasing. Or you could say the rate, that's the acceleration of the bananas. Either way would work for that. Part C, and again, this is a heavy calculator, is the number of pounds increasing or decreasing at time t equals 5. So what we need to do is find out the rate at which they're being removed at t equals 5 and the rate at which they're being added at t equals 5, and figure out which one's bigger. The 50, the initial amount, does not matter as far as whether the bananas are increasing or decreasing. So g of 5 minus f of 5. So I've already got f plugged into my calculator here. So if I want f of 5, I can just go value x equals 5. That gives me this 13.796. And then I can go back and I can type in g, so I can get rid of this one. And g is 3 plus 2.4 times ln of x squared plus 2x. And we'll graph that. And I want to know what happens at 5, so I want to find the value at 5, so we'll see if we can find it. 11.533. And if you subtract those, that's where I'm getting the negative 2.263 from. And a negative rate means bananas are decreasing at t equals 5. So at that moment in time, more bananas are leaving than are entering. Part D has how many pounds of bananas are there at t equals 8. So there are 50 to begin with. We have to add the amount that entered, and we'll subtract the amount that was removed. So this comes from integrating the rate. This comes from integrating the rate. So 50 plus. Here you're only integrating from 3 to 8. It'd be really easy to integrate from 0 to 8. But remember, the bananas don't start entering until time equals 3. But they're being removed the whole time, so you do subtract the integral from 0 to 8. And I'm going to let you guys type those into your calculators. Try them out yourself. If you have questions, we'll look at doing the Zoom tomorrow. And there you go. All right, number 3. Well, 3 is a topic we covered, but this is a hard version of it, and it's been so long since we've done it. So they're giving me, this is f prime. So this graph is the derivative graph. There is a graph above it that is f. There's a graph below it that is f double prime. So this derivative graph tells us about, derivative tells us about the slope of f. I've got these little numbers here. I'll talk about what they're there for in a little, well, I can tell you now and then we'll use them in a little while. It's the area of each of these sections. So like this is 1/2 base times height. The base is 4, the height is 2, so it's 1/2, 4 times 2, which is 4. This is 1/2 base times height, and that's 3. And then this is half of a circle with radius 2. So this would be like pi r squared, where the radius is 2, but you only have half of that circle, so that's 2 pi. Because we're going to work with areas there in a little bit. Part A, find the values of f of -6 and f of 5. Well, we have f prime, and we want to go to f. So the first thing is I got to find the value of f of -6, and I know the value of f of -2. So how do I get from f prime to f? Is I integrate, and I'm going to integrate from -6, which is what I'm looking for, to -2, which is what I know. I'm going to integrate the derivative. That's going to give me the original, and then -6 to -2. Well, this has a value that I can figure out, and that's that 4 that I was pointing out a second ago. This integral from -6 to -2 has an area of 4. So that's where this 4 comes from. Well, working on the other side, you plug in the top minus you plug in the bottom. So f of -2 minus f of -6. And then f of -2 is 7. And then if you just work that out, you get f of -6 equals 3. So the idea there is that this original graph has an accumulated area of 3 at this spot. When you go over to here, you've accumulated 4 more units of area, so now you have 7 units. And then we're going to keep going. So now they're saying, what about f of 5? So if you just think about it through the graph, we've got 7 total units here. We're going to lose 2 pi units here, so 7 minus 2 pi. And we're going to add 3 units here, so we should end up with 10 minus 2 pi. So that's like a graphical way to think about it. The algebraic way to think about it would be the same thing we just did. I'm going to use -2 because that's what I know. I'm going to use 5 because that's what I'm looking for. I'm integrating the derivative to end up with the original. And then this, I know this area. There's 2 pi below the axis and there's 3 above it. And here I know I'm supposed to plug in top minus bottom. And then if you just work through the algebra, this is what we said we should get. F of 5 equals 10 minus 2 pi or -2 pi plus 10, whichever way you want to say that. And what intervals is f increasing? Well, f is increasing if it has a positive slope, meaning if it has a positive derivative. So we are increasing as long as this graph is above the x-axis. So there from -6 to -2, and from 3 to 2 to 5, because the derivative is positive in those spots. Part C, absolute minimum. There were 2 of these in the last one. You'll notice another one right here where they're making sure that you understand to check critical points and endpoints. This type of question that we're going through here seems to me to be a pretty good one to put on a test, because obviously they like the absolute max or absolute min. And this question makes you understand going back and forth between derivatives and integrals, finding some areas, finding some slopes. I think it's a good type of question that can cover a lot of ground for them, since they only have 2 questions to ask. But anyway, the absolute min means you got to check 2 types of points: endpoints and critical points. The endpoints are -6 and 5. Critical points are -2, 2, and 5, and the critical points come from when the derivative is 0. So I'm using that, and that. And then you'll notice 5 is on here twice, because it's a critical point and an endpoint, so I don't really need it twice, but it's certainly not going to hurt to have it. And then what I'm doing is finding the y value at each of those spots. Well, we found this one was 3. We found this one already in part B. That's 10 minus 2 pi. At -2, they told us it's 7. That's just the answer. We already know this one. And then at 2 is the only one we didn't have. So right here, the area was 3. By the time we got to here, we added 4 more units, so now it's 7. By the time we got to here, we subtracted those units, so now it's 7 minus 2 pi. And that actually is the lowest y value, so that ends up being your absolute min. Then part D, as for the second derivative of -5 and 3, or tell me why it doesn't exist. So the graph we're looking at is f prime. So f double prime is the derivative of this graph, which is the slope of this graph. So -5, -2, -3, -4, -5 is right here. I know I've destroyed my graph by now, but you want the slope of this little piece, and this little piece goes down to over 4. So we go down to over 4, so our slope comes out to -0.5. And then f prime of 3 doesn't, f double prime of 3 doesn't exist because you're asking to take the derivative here. So the derivative, if it's going to exist, needs to match. In this case, we get a positive derivative from this side and then like a negative after, and I wouldn't know which one to use. So f double prime of 3 does not exist because it's a corner, so it's not differentiable. All right, number 4. This is the toughest one, or probably the toughest one for you guys because it's the topic that we just didn't get to. But it's not impossible. So number 4, they give you the whole setup about the boiled potato. I'm not going to read that to you. Write an equation for the tangent line. So our equation is always y equals blank times x minus blank plus blank. And what goes here is the x value. What goes here is the y value. And then what goes here is the slope. And to get the slope, we plug into the derivative. So the derivative is this dh dt equals -1/4 times h minus 27. And h represents the temperature, and h of 0 equals 91. So we're going to end up putting 0 here and 91 here. But what goes in here is actually h. I think it's pretty easy to put 0 there, but h represents the temperature. So -1/4 times 91 minus 27 gives me -16. And then the -16 goes in this slot up here, and this becomes the equation of our tangent line, which I wrote out again down here. And so you'll get this. And then they're saying use it to estimate the internal temperature when time equals 3. So if I plug 3 into that, I get 43. All right, part B asks for the second derivative. Just realized I never finished this problem. So dh dt is here. The second derivative of -1/4 h should be -1/4 times dh over dt. Well, dh over dt was -1/4 times h minus 27. So what we actually get here is a positive 1/16 times h minus 27. And then h is 91, or h, it doesn't really matter. H is going to be a positive number. So this second derivative comes out positive. So if the second derivative is positive, that means that the original function is concave up. And we wanted to estimate the slope at 3. So let's say 3 is here, but let's look at our function as concave up. Well, if I use a tangent line to estimate at 3, but the actual graph is curving up, just think about, am I going to be an overestimate or underestimate of that y value? So in my kind of setup here, I'm using the tangent line to find information, and the tangent line does not curve up, but the actual line does. So I'm going to be underestimating the actual answer there. And then part C. Okay. Again, this is the stuff we didn't get to. It's not that bad. It's just hard because you never saw it. So they're giving you dg over dt. So this is a rate equals, and they're telling you this, and then they're giving you g of 0 equals 91. And then they ask you for g. So we're going to have to integrate that. So the first thing we need to do is split up variables. So we need to get all the g's on the left-hand side, all the t's on the other side. So I started off by just exchanging those two guys. So it gets me to here. Then I brought up the g to the minus 27, so it's to the negative 2/3 because I don't want it on the bottom, equals -1. And then I integrated both sides. So there's no u substitution necessary here because the derivative of the inside is 1. So I can just add 1 to the power and multiply by the reciprocal of the new power. Over here it's just -t. And then I'm going to use this information to plug in here and find out what c is. So 91 goes there, 0 goes there, and I come out with c equals 12. Well, now I can take this equation that I had a minute ago and write a better version of it. So I'm smarter than I was 10 seconds ago, and now I know that c is 12. And your job now is to get g from here to get g by itself. So I multiplied everything by -1/3 first to make that go away. I'm sorry, by 1/3 to make that go away, and then this is going to be 1/3, and this is going to be 4. And then I cubed everything, and then added the 27 to the other side. And then what they're saying at the very end, find an estimate for t equals 3 here. So I plugged in 3 to this, worked that out, and got 54. All right. Again, that's tough without spending any time on it. Hopefully that helps some. Number 5. Keep in mind you have a calculator on this too. So these will actually, they'll know that, so I'll set them up with that in mind. But some of the stuff, there's only so much they can do. You're going to be able to kind of, I don't want to say cheat, but use your calculator to help you. Okay, so we got two particles here. We got P, and for P, they gave us that the position of P is ln of t squared minus 2t plus 10. And so we can find the velocity there. So the velocity for P is going to be 1 over 2t, or t squared minus 2t plus 10 times the derivative of the inside. For Q, they gave us the velocity. So the velocity of Q, they told us that's t squared minus 8t plus 15. And I might need to find the position of Q. I can't really remember. Or I might need to find the acceleration of Q. It should be 2t. I could do these right now. I don't know if I'm going to need them. This would be 4t squared plus 15t plus c. So you probably won't need that one, but just in case. So I got these two particles, and they're going to ask me a bunch of questions about them. Part A, when is P moving to the left? Well, for P, they gave me the position. So moving right and left has to do with velocity. So I found the derivative. This is what I wrote on the previous page. And then just multiply the top times 1 and put it all together. And that's your velocity function. So you got to find critical points. So to do that, you set the top and bottom equal to 0. So setting the top equal to 0, I just get t equals 1. Setting the bottom equal to 0, I get t equals 5 and t equals -3. I'm not going back in time. So t equals 1 and t equals 5 is all I'm concerned about. I set up my intervals based on those. I'm not going into negative time. I'm not going past t equals 8. And then I'm plugging a representative point from each of these into the derivative. So I'm plugging it into here. So for example, if I plugged in 0.5, well, 2 times 0.5 is 1. 1 minus 2 will leave me with a negative number on top. And if I plug 0.5 into the bottom, this is like 0.25 minus 1 and then plus 10. So you're going to get a positive number on the bottom. So negative divided by positive is a negative. And the other two cases, if you plug into there, you'll get a positive. So it's only moving left in this one little situation where we're from 0 to 1 and the derivative came out negative. Part B asks, when are the two particles traveling in the same direction? So for Q, I have to look at the velocity and kind of repeat that process I did in A and see where the velocity is positive and negative. So if I solve, remember they gave you the velocity, so don't take the derivative of that because you'll be at acceleration. Set the velocity equal to 0, top and bottom, but there is no bottom. You get 3 and 5. These are your intervals. Again, we're not going negative. We're not going past t equals 8. I'm going to pick a point in each of these spots and plug it into the derivative. So you can use that or that, whichever is easier for you. But you should get plus minus plus. And they're saying when do they travel in the same direction? So then I just made this little number line. So for P, and I put all these spots on there, 1, 5, and 3, kind of like we did when we were graphing the data. And then for P, it was negative from 0 to 1 plus the rest of the time. For Q, it was negative here plus the rest of the time. And then I just noticed, okay, they matched up in those two spots. Part C, find the acceleration of Q at t equals 2 and tell me if the speed is increasing or decreasing. So acceleration is the derivative, which is the 2t minus 8. I plug that in, I get a negative 4. Well, they're asking about speed. So if you remember this chart we have on the board for speed, if the velocity and acceleration have the same sign, we're speeding up. So think about if I'm moving forward and I'm moving forward faster, I'm speeding up. If I'm moving backwards and I'm moving backwards at a more negative rate, that's also speeding up. And if your velocity and acceleration are opposite signs, your speed is decreasing. So what that means is back up here, I have to also find the velocity. So I plugged 2 into the original equation and found the velocity is 3. So if I've got a positive velocity, so I'm moving forward, but I'm being pulled in the negative direction, that is a decreasing speed. So this would be like I just saw a stop sign, so my velocity is still positive because I'm still moving towards that, but my brakes are accelerating me backwards. So my speed is decreasing. Part D, find the position of Q the first time it changes direction. So it changes direction at t equals 3. And so we knew that from above. Right here, the first time it changed direction was positive to negative, so it happened at 3. And they're saying, what's the position? So first of all, how do we go from velocity to position as we integrate? So you're going to integrate this from 0 to 3, and you can do that by hand if you want, but you have your calculator, and you will on the exam. So I just plugged that in and got 18. Why am I adding this 5? Because it tells me here particle Q is at position x equals 5 when t equals 0. So this is where it started, and this is how far it moved during those 3 seconds, and that gets you to 23. Use your calculator. Number 6. Okay, so they give us this. They got a table and a chart, and this is the graph of H. We also have G, and we also have F. So F is a graph, G is a table. I'm sorry, H is a graph, G is a table, and F is an equation. So then we're going to have to work with those. So find the slope of the line tangent to the graph of F. So first of all, that puts me in this equation, not the table or the graph, at x equals pi. So equation of, find the slope. So find the slope means take the derivative and plug in. Now, again, you can use your calculator on the AP test for this. That doesn't mean they can't write a question that kind of works around it, so you still should know how to do this. But if it's presented to you on the AP test, don't be a hero, use your calculator. Here's the original equation. So when you're taking the derivative of that, it's 2 chain rules. So the derivative cos is negative sign. Leave the 2x alone, multiply by the derivative of the 2x. E to the whatever, the derivative is e to the whatever, times the derivative of the whatever. And then if you plug in pi, you'll get -1. And certainly don't take time to do something like this on the test when you have a calculator right in front of you. I know sine and e and all that stuff in your head is not the easiest for some of you guys, but the good news is you're not going to have to do it. Okay, K. Part B, K of x is h of f of x. So now we're involving these. So we're putting in this composite function, it's called, and we're going to need to find the derivative of that. Well, that's chain rule. So if k of x equals h of f of x, the derivative says you take the derivative of the outside, you leave the little guy alone, and you multiply by the derivative of the little guy. And then I plug in pi here. Remember, this is still a composite function, so I've got to find f of pi. Well, f of pi means I have to plug pi back into this original equation up here. again, we can talk through that. Cosine of 2 pi is 1. E to the 0 is 1. So when I do that, I'm going to get 2. But you just use your calculator. There is no benefit to fighting through it in your head, especially because you got a time issue. So this is 2, and then it's h prime of 2. So you plug pi into the f, and then that answer into h prime, and that gets you negative a third. And f prime of pi, we just did up here, that's negative 1. And I should explain how I'm getting this. H prime of 2, where'd that come from? H prime, so this is 2, but prime is the derivative. So I'm looking at this going, okay, the slope there is down 1 over 3. So that's the h prime of 2, and if I multiply those, then I get 1/3. Part C, m of x equals g of negative 2x times h of x. So we've got the table and the graph, and we've got a product rule. So the product rule tells us, and this is how they can kind of force you to take derivatives by hand, because you can't throw this in your calculator, you know, so you got to know the rules. The second thing times the derivative of the first thing, don't forget the chain rule piece of that, plus the first thing times the derivative of the second thing, and there's no chain rule piece there because the derivative of x is just 1. Then we plug 2 into all those, and then I'm just plugging into the chart. So h of 2 is just reading off of this. So what's the y value here? I know that's negative 2/3 just based on the slope. If it went down 1 and over 3, it must have gone down 2/3 and over 2 type of thinking. G prime of 4, I'm sorry, G prime of negative 4, that should be. So if I go to negative 4, G prime is negative 1. Negative 2 is just negative 2. G of negative 4 is 5. And then, so I'm just plugging in from the chart, multiplying across, and you get 3. Part D, is there a number between negative 5 and negative 3, so between there and there, such that the derivative is 4? Well, first of all, they told me it's differentiable. That means it's differentiable, it means it's continuous, it means all of our theorems are okay. The mean value theorem specifically is okay. So is there a spot where the derivative equals negative 4? Well, yeah, because if I found the slope between these two, 2 minus 10 over negative 3 minus negative 5 would be negative 8 over 2, and that's negative 4. So because there is the slope between the endpoints is negative 4, there must be a spot where the derivative also equals negative 4. So here's my work for that. So mean value theorem is okay because the function is differentiable. So does the slope between the endpoints, question mark, equal the negative 4 that they gave me? And so I'm working through that. I found that out, and I do get that there's a spot. You know, if I plug in the endpoints, I get negative 4, so that does work. All right, so I hope to see some of you guys at the Zoom call tomorrow. Just stop in and say hi if you can. And that's all for now. Let me know if you have questions.